Hi everyone. And in this part of the video, we're going to pick up here with the law of cosines. So now that we've learned the law of sines, which works every single time we have an angle and side that are opposite that match in non-right triangles, there is a second law that works called the law of cosines. Now this exclusively works when you have all three sides of the triangle or you have two sides and the angle between them. In every other case, the law of sines can be used. The law of cosines can only be used in these two cases. And basically, the formula is a modified version of the Pythagorean theorem, c squared equals a squared plus b squared minus 2ab cosine of angle C. So basically the thing that I do every single time is if I am given an angle, I just redefine that angle as angle C, and I just make everything else A and B relative to it. So nothing else really matters. And then if I want angle C, I call it that, and everything else is labeled. So let me show you how this will work. So using the triangle on the right, find the value of side A. So again, they give me this angle, so I'm just going to redefine my variables here. So this is C. I'm going to call this little c now, and then A and B. Because now that I have all the pieces, since I know that angle, it has to be across from the side I'm trying to find. See how this fits in my side angle side definition? Because I have this side, and the angle that's between them. This is why I can't use the law of sines, because I don't have a matching side angle combo anywhere. So I'm kind of forced to use it. So the way that it works is it's the missing side squared equals 15 squared plus 17 squared minus 2 times 15 times 17 cosine of 30 degrees. Now, part of this should be kind of nice because it is just the Pythagorean theorem. So as I'm putting this into my calculator, this equation can be put into your calculator exactly as is. Just make sure you are in degree mode because that's the value that we were giving. And so when I plug all of this in, I get c squared equals 72.327. And then I take the square root of that number. So that'll give me roughly 8.5. 04, and this unit would be, it doesn't give me a unit. So, okay, and again, it kind of makes sense because 30 degree is most likely the smallest side of this, or smallest angle in this triangle, and therefore we don't really need to do much more with it. Now here's the case where we have find the value of the obtuse angle. So they give me the three side lengths. So first I want to start off by drawing the triangle. So 8, 14, 19. And I want to find the obtuse angle, which if you remember in sort of the hinge theorem of a triangle, that the obtuse angle has to be across from the largest side. So we are going to call the angle across from 19C. So we're going to make that the C, 19. 8 is little a, and 14 is little b. Once I have all that, I just plug everything in. 19 squared, equals 8 squared plus 14 squared minus 2 times 8 plus 14, or times 14, cosine of big C. This is what I am going to ask you to do for your work because everybody makes a mistake with this. Find this as a piece, find this as a piece, and find this as a piece, like individual components. So in my calculator, I'm doing 19 squared. That's where I get the 361. Then I am putting 8 squared plus 14 squared in my calculator. That's my second component. That's 260. Now I'm doing 2 times 8 times 14 in my calculator. Minus 224 cosine of C. If you think you know where I'm going with this, you're probably right. Everybody thinks they can combine these. You cannot combine these two values here. Effectively, this is the same as 260 minus 224x. You can't combine them here. You can't combine them here. So what we're going to do is subtract the 260 on this side. So I get, I'm going to have to move over to the left here. So I get 101 equals negative 260 cosine of C Divide both sides by the negative 260, so 101 divided by negative 260. And I'm going to bring it back over here so I have space. I get negative 0.388 equals cosine of C. And then again, I just do the inverse angle. Oops, I hit the wrong button in my calculator. And so I get cosine inverse of negative 0.388. That gives me an angle of 112.859. That's the angle. Okay, and now we have another example here using bearings. Two planes leave an airport at the same time. The first plane leaves due west at 500 miles per hour, and the second plane flies south 45 east. So let's draw the first plane. So let's say this is the airport here. Due west means it's literally just going to the west, directly to the west, no angle. That's going to be 500 miles per hour. The second one is going south due east. So if you remember, we make our border line here, and we pivot 45 degrees out this way, and that's a speed of 300 miles per hour. How far apart are they after 2 hours of travel? So now that we have the directions, let's try to build our triangle. So in this triangle, after 2 hours, this first airplane traveled 100 miles, the second airplane traveled 600 miles, and the angle inside has to be both the 90 and the 45, so it's 135. I want to see how far apart directly they are. So since we have that angle C, I can use the law of cosines because once again, I have the side and the angle between them. So law of sines, unfortunately, I don't have a way to work through that. So I have to use the law of cosine. So C squared equals 1,000 squared plus 600 squared minus 2 times 1,000 times 600 times the cosine of 135. Okay, this is a really big number. So when you solve this equation, just take your time. It is a very large number. I'm not going to do all the computation because this is just plugging it in at this point. But you do get a very large number. I want to say it's somewhere in the 1200s or something like that, but that's the way it works. Okay? And the last thing I'm going to show you for this lesson is Heron's formula. So Heron's formula is actually really easy. It's a way to find the area of a non-right triangle by just knowing the 3 sidelines. So if you know the 3 sidelines, A, B, and C, we solve for what's called the semi-perimeter. And just like a semicircle, it's just half of the perimeter. That's why the formula for S is A plus B plus C over 2. It's just the semi-perimeter. And once you have it, you literally just plug everything into this formula. The semi-perimeter times the semi-perimeter minus the one side, minus the second side, minus the third side, and then you take the square root of it. It's very formulaic. So we're just going to do one quick example here. If I want to find the area of this non-right triangle, I first want to find the semi-perimeter, which is just 11 plus 7 plus 5. Divide that by 2. So 11 plus 7 plus 5 gets me 23. Divide that by 2 is 11.5. And now to get the area, it's the square root of 11.5 times the difference of each one. So 11.5 minus 11, 0.5. 11.5 minus 7, 4.5. And 11.5 minus 5, 6.5. I literally just find the difference of each individual one with the semi-perimeter, multiply them all together, and then take the square root. So when I do the square root of this answer, I get roughly 13 with some rounding. It's kind of a big number to round with, but 13, okay? So that's really it to find the area. Now, if you were wondering, could you break it into other triangles, find the area of individual triangles, making right triangles? Yes. Does make it a little bit harder without any of the angles, however. Okay? So I hope this lesson was helpful, and let me know if you have any questions. See you in the next one.